We're going to be talking about special right triangles. So today and tomorrow we're going to go over special rights. Today specifically we're looking at the 45, 45, 90. Okay, so when you have a 45, 45, 90 degree triangle, the legs are congruent. Okay, so the legs are congruent, and my pen is not working, of course. Right. So the legs are congruent, and then the length of the hypotenuse, h, is going to be square root of 2 times longer than the length of a leg. So the formula that you guys are going to want to remember is h equals L square root of 2, where hypotenuse equals leg square root of 2. Okay, and this can be pictured in this image right here. So for some people it kind of helps to have a reason why behind the formulas we use. So we're going to take an opportunity to kind of look at the Pythagorean theorem in relation to the 45, 45, 90 triangles. Okay, so here we have a square. We know squares are congruent on all sides. So we can call these congruency marks L for the legs. And then we have this diagonal that goes across. Okay, this is the hypotenuse of our triangle. So we know it's a 45, 45, 90 because remember, a corner is 90 degrees, and if we're cutting it in half, 45 degrees is what's left, okay? So where we get this h equals L square root of 2 from? If you're thinking of the Pythagorean theorem, okay, c squared equals a squared plus b squared. C squared is technically your hypotenuse. So hypotenuse squared equals, and then A and B are going to be the legs of your triangles. So L squared plus L squared. Okay. Once we're here, we have h squared again, and we need to simplify. So L squared plus L squared is going to be 2L squared. Okay. We're just doing a little proof. And then we want to find the length of our hypotenuse. So we take the square root. All right, the square root of h squared is h. That's going to be equal to the square root of L squared, which is L times square root of 2. Okay, so this is kind of the proof of how we get this formula. Okay, so let's look at it in an example when we have numbers. So in our first picture, okay, we have this triangle. We have a 90-degree angle in the corner. Down here is 45 degrees. Whenever you have a right triangle, the complementary, or the acute angles are going to be complementary. So they have to add up to be 90 degrees. So this angle is 45 as well. Okay. Thinking of our formula, h equals L square root of 2. Okay, we need to find our hypotenuse. So that is the side opposite our right angle. And then our leg is, in this case, 6, okay, because it sits on that right angle. So let's plug in our values. H equals L, which is 6, and then square root of 2 from our formula. And that is actually our answer, okay? It might seem a little extra simple, but sometimes that's how these work out, depending on the numbers given. Okay, so here your answer, hypotenuse equals 6 square root of 2. Okay, moving on to the next example. All right, let's label what we have. All right, our hypotenuse is our missing length. We have 2 congruent legs. Okay, they are 9 square root of 2 as values. So let's find out that hypotenuse value. Okay, start with your formula. Hypotenuse equals leg, which is 9 square root of 2, times the square root of 2. Okay. Once we're here, we need to simplify out these radicals. Okay, so we're going to have the square root of 2 times the square root of 2, which is the same as the square root of 4. Okay. And if you think back to last week when we talked about perfect squares, the square root of 4 is 2. Solving out your hypotenuse, we're going to have 9 times 2, okay? And again, that 2 comes from simplifying out these 2 radicals. Okay, so our hypotenuse is a length of 18. Okay, So that's how we find the hypotenuse of our 45, 45, 90s. Now let's look at finding the legs. Okay, so here we have these missing leg values, and we're given a hypotenuse of 12. Okay, good thing is you don't have to memorize another formula, guys. So you're still going to use the hypotenuse equals leg square root of 2. Okay, that's just your 45, 45, 90 theorem. Okay, you're going to substitute in the values that they give you. Your hypotenuse was 12. We're looking for the leg length. Okay, so they called this x. And then now we just need to start solving. Okay, so we have to divide by our radical. Okay, so we can cancel this out. That's going to leave us with x, or our leg, being 12 over square root of 2. Now here's the thing that might seem a little new. You should have learned in Algebra 2 how to do something called rationalizing your denominator. So rationalize the denominator. Okay, what that means, we need to get rid of this radical on the bottom. Okay, so in order to rationalize our denominator, you have to multiply by that same radical, okay, in the form of a fraction, right? Because what that does, when we multiply across, it's going to get rid of the radical, and I'll show you how. Right, so we are multiplying straight across. So now I'm going to have 12 square root of 2 over, and I want to write down each step so you guys see how this works out. So square root of 2 times square root of 2, okay? Here, if we do 12 and then 2 over the square root of 4, okay? Then we're going to simplify down a little bit more, 12 square root of 2 over 2, okay? So this is going to be our simple form. But we need to look and say, okay, I have 12 over 2. Can this right here reduce any more? 12 over 2. All right, it can. So our leg is going to be a total of 6 square root of 2. Okay? So one little thing I wanted to show you guys. I'll show it in a second, actually. Okay? So we have just a few more examples. We're almost done. Right? So here we are still looking for our leg lengths. We are given our hypotenuse. So leg square root of 2. Our hypotenuse is 5 square root of 2. Our leg is what's missing. So let's solve for that. Okay? Just like we did before, we need to divide by that radical. Okay? So here we're going to have L equals. Now look right here. Remember we divided right here by square root of 2? So we had the same values one over the other, and they canceled out, right? Let's make our lives a little easier on this side. If you can rationalize your denominator in the sense of canceling out, do that. Okay, so we have square root of 2 over square root of 2. That is going to cancel. So we are left with our leg being a value of 5. Okay. So this will not always work, but if you have the same radical top and bottom, cancel it out. Okay. Let's look at one more example of these. Okay, so again, we're looking for our leg. We know it's a 45, 45, 90 because we have a 90-degree angle. And then these two have to be complementary, so this is 45 as well. Okay, start with our formula, leg square root of 2. Our hypotenuse is 18. We are looking for our leg value. Okay, so here we again divide by square root of 2. Our leg is equal to 18 over the square root of 2. This is the part where we need to get rid of the radical on bottom. Since we don't have a radical on top, we still have to rationalize. Okay. All right, so in order to rationalize, remember you multiply by that square root of 2. Okay, going straight across, you'll have 18 square root of 2 over, if we do the square root of 2 times the square root of 2, we have the square root of 4. And if you can see the things that are going on, you can skip certain steps if you can see what comes next. But for note-taking purposes, I want to show you guys what I'm talking about. Right, and then the square root of 4 is 2. Okay, last step, check your integers. Can they reduce? They will reduce to 9 square root of 2. And that is your leg length for that triangle. So last two examples. Okay, so here we have the sides of a square being 12 inches long. We need to find the length of the diagonal. So draw a picture. So our square has congruent sides all the way around. 12. Okay, we want to find the length of our diagonal. Okay, so this is our hypotenuse because it is opposite the right angle. We're going to use our formula h equals L square root of 2. Okay, so h equals, plug in your leg value of 12 square root of 2. And that is actually the answer for your hypotenuse. Okay. And then last but not least, the diagonal of a square garden is 32 feet. How long is an outside border of the garden? Okay, so if we have our square garden, we'll color it green. We know it's square, so all four sides are congruent. We want to find the outside border length, and we're told the diagonal is 32 feet long. So hypotenuse equals leg square root of 2. Okay, we have 32 being our hypotenuse length, equaling our missing leg value, square root of 2. Now we need to simplify, get that L by itself, so we divide by square root of 2 on both sides. We have leg equals 32 over square root of 2. And then here we need to rationalize. Okay, so we multiply by square root of 2 over square root of 2. As we go straight across, or left to right, we are going to have 32 square root of 2 over the square root of 4, which is the same thing as 32 square root of 2 over 2, because the square root of 4 is 2. And then we need to determine, can we reduce these two integers? Okay, 32 over 2 is 16, so our leg of our square garden, that outside border, is 16 square root of 2.